Hey, hello, this is Dr. Lennon, and I want to walk you through the third question on the Chapter 15 assignment, which is another decision tree analysis problem. This one has an interesting choice. So there's a winery that purchased some land for a new vineyard, and they have some projections on different markets and probabilities for how they want to decide what type of grapes to plant. So there's Riesling and Chardonnay, and they have weak and strong markets. So the options for them, they need to make the choice whether to plant Riesling only, plant Chardonnay only, or plant both grapes. And after that, during the market and harvest, you'll find out whether the market is weak or strong. So the first question asks you to choose the appropriate decision tree. So the decision here, weak or strong, you're not going to know first. So one can't be correct because we have to make the decision about which style of grapes we're going to plant, and then only then after can we determine what the market looks like for each of those wines. So option 2 has the correct first decision: plant Chardonnay, plant both, or plant Riesling. If you plant Chardonnay only, there's two options. It's either weak or it's strong. If you plant Riesling, there's also two options: weak or strong. And if you plant both, it's either weak for both, weak for Chardonnay, strong for Riesling, strong for Chardonnay, weak for Riesling, or strong for both. So we need to make sure the probabilities match. So number 3 also has the same outcomes, and number 4 has the incorrect first choice of weak versus strong. So it's between 2 and 3. We just need to decide which probabilities match the information that we're given. So if we look here, for instance, Riesling has a weak market of 0.05, when Chardonnay is also weak, and when strong, 0.25. So maybe we can use that. So when they're both weak, it's 0.05 for Riesling, and let's take a look. Let's see how these match up. So this one has 0.55 when it's weak for Chardonnay. So does that make sense? So 0.55 in option... Oh, sorry, I'm looking at the wrong one. We need to compare 2 and 3. So 0.55 weak for Chardonnay in option 2, and 0.55 weak for Chardonnay option 3. That matches. 0.45 in 2 in strong, 0.45 here in strong. So let's look at the second branch, planting both. 0.05, 0.25, 0.05, and 0.5. So we see a difference here in weak for Chardonnay and strong for Riesling. So let's look at the table and figure out what does weak for Chardonnay and strong for Riesling look like. If you plant both grapes, so if you plant both grapes, weak for Chardonnay and strong for Riesling comes out to, so this is the Chardonnay demand, weak, and Riesling strong should be 0.50. We get this value right here, 0.50. So which of those had 0.50? This one had 0.25, which is incorrect. This one has maybe I looked at the wrong one, strong for Chardonnay. So let's see. I looked at Chardonnay demand, weak for Chardonnay, strong for Riesling. Unless I'm looking at this backwards, the chart's kind of hard to tell. So let's see if we can see it up here in the word problem, with the help of some forecasts. Okay, I got confused for a second, but I don't know why. We were reading it correctly. Weak for Chardonnay and strong for Riesling should be this 0.50. So let's compare the two. Option number 2, weak for Chardonnay and strong for Riesling, it says 0.25, which is incorrect. And then option 3, planting both grapes, weak for Chardonnay and strong for Riesling, 0.5. So we see that decision tree number 3 is correct, and the probabilities match. So we're going to choose option 3 there. So now it says use the expected value approach to recommend which alternative Seneca Hill winery should follow in order to maximize expected annual profit. So first let's determine the expected value for planting only Chardonnay and for planting only Riesling. That should be pretty straightforward. Okay, so using the expected value approach, like I said, we're going to do Riesling only and Chardonnay only. So first what I did was I copied charts above into an Excel sheet. So we have the probabilities, the two-way table for Riesling and Chardonnay, and then we have the two-way probabilities based on the market. Oh, a little typo there. Week, not day of the week. So if we're doing the expected value for Riesling only, what we're going to do is notice if you add up all four probabilities, they do add up to 1, 0.55, and then 0.45 make 1. So if we're talking about Riesling only, the Riesling market is weak 0.05 plus 0.25. So it's weak 0.3%, 30% or 0.3 of the time, and 0.7 or 70% of the time the Riesling market is strong. So what we need to do is figure out what the Riesling market is and then multiply. So we're going to do, it's weak, so the expected value will be 0.3 because Riesling is weak 30% of the time, and we're going to multiply that by the price that we get for Riesling when it's weak. So the price that we get for Riesling when it's weak. So to figure out the price we get when Riesling is weak, we have to actually go back to the old MindTap table, and it actually tells us here. So notice it gives the expected revenue projections for Chardonnay weak 20,000, strong 70,000, and for Riesling 25,000 weak and 45,000 strong. So this two-way table that I've copied into Excel is essentially only giving us the projections when we plant both grapes. So let's remember for the Riesling we've got 25,000 and 45,000, and then move back to Excel. So 30% of the time revenue of 25,000, and 70% of the time we have a revenue of 45,000. So that's the expected value of Riesling only. And now for Chardonnay only, let's remember the numbers for weak and strong. And for Chardonnay we have to go across, so 0.55% of the time it's going to be weak, and 45% of the time it's going to be strong. So we need to go back to the MindTap question, and we have 20,000 and 70,000 for weak and strong revenue projections respectively. So let's go back here, 20,000 and 70,000. Just giving one last look. So we're going to be doing equals 0.55 times 20,000 plus 0.45 times 70,000. So we get both of our expected value approaches there, and now the tricky part, the expected value for both, which is actually not too bad because everything matches up. Week and week we have 22,000 revenue projection on average, 0.25 times 26,000, 0.5 times 40,000, plus 0.2 times 60,000. So if you want to do it all in one function, you can do sum product and match here, but since it's a pretty simple one, we can just go one at a time. If you're not too worried, just do this cell times this cell plus this cell times this cell, and just match them all up. This cell times this cell, and this cell times this cell. And we get our three expected values that we're comparing. So planting both is a little better than planting Riesling, but planting Chardonnay only at 42,500 is the best bet. So let's go back to the question and see if we got those right. So the expected value approach, we predict Chardonnay is the best. Okay, and then for questions D and E, it's really not that much different. We're just changing some of the parameters and the probabilities. So for part D, it says some believe it's likely for Riesling demand to be strong in this case. Suppose the probability of strong demand for Riesling and weak demand is 0.05 and 0.4. And then Chardonnay demand is weak are 0.05 and 0.5. So what you're doing there is you're just taking your table here for the two-way profit and you're altering that. And if you just alter these formulas, then it'll automatically update the expected value. And then in the very last question, they are updating the revenue projections to correspond based on someone else's idea for the revenue. So they say, suppose the annual profit projections fall to 50,000 when you have Chardonnay being strong and only Chardonnay are being planted. So actually that's not the two-way recommendation, that's changing the formula for Chardonnay only, because the original Chardonnay only revenue projection in the strong market was 70,000, so you're changing that to 50,000. And you just need to update those. let's check our work, and I think we got a good handle on this one. So we picked the right decision tree, I believe, and we have the right choice here, and all you have to do left is alter that spreadsheet to figure out D&E. So hopefully that helped with this decision-making problem. And that's all.